The world is moving at a rapid pace, and the question is, are you keeping up? Are you able to operate in a world in 5 years where AI will be much more prominent than it is even today? That's what Optimal Ops is about, and we'll get into here. The US is lagging the rest of the world. The US has about 29% using AI somewhere in the facility and 38% piloting AI solutions. But when you go to other countries like India and China, you'll see these percentages much higher than us. So as we face the next few years of AI becoming more and more pertinent to everyone, and we have more lights out factories being built around the world, having mature processes underneath is going to be key to be able to create a lights out factory. And we're proposing that Optimal Ops is one of the mechanisms to help out in that way.
68% of optimization initiatives have failed to deliver expected ROI. It's because they're optimizing to yesterday's optimum and using yesterday's assumptions, and all of the things like fatigue, operational drift, unpredicted failure modes, all of that goes uncaught with that type of modeling.
So very often we work on the assumptions of normal distributions and averages, and that creates a performance gap. In manufacturing, supply chain operations, they're constantly changing. So taking the average of an average and then making a decision, you end up with subpar decisions. And you miss critical shifts in the operations. 50 years ago, even 20 years ago, we were not able to manage that in real time. But with today's technology and Optimal Ops principles, it can easily be modeled. So I'll go into the first case study here of a turbine generator trip that happened a number of years ago with a client, and they did not address the root cause. They thought that the root cause for this generator failure was due to moisture. And then a number of years later, they had the same failure again. Well, they didn't really get to the root cause. They weren't looking at the data. They were looking at the answer and trying to work backwards to a problem. The real problem was that these generators were not built for this application. This goes back to first principles. These generators were meant for steady state operation. And if they were using Optimal Ops and looking at the underlying data, they would have caught what the problem is. Irene, another example?
Talk about an example, again, from an energy from waste facility, and want to explain a little bit about it. When you get a spike in the level of BTUs that waste produces, it reduces your throughput. There's only so much that it can handle. So you have to really manage this. And with the financials for these type of companies, throughput is where you're going to get your revenue, especially in this current trend where it was the amount of waste being brought in was critical versus the energy produced. This real world case, that sudden spike, you could see after like week 5, it just started trending up through week 8, really significantly limited the plant throughput. So they collected some data across all the systems, saw some patterns. They also identified, in addition to that, some drift in the performance of a heat exchanger. So it was within specs, but it was still below that operational optimal. And then using that constraint-based systems thinking, we adjusted the operations and implemented early warning triggers. And so the business impact for that is $1.4 million annual savings. They were able to implement it in 3 weeks, able to reduce energy savings of 12%, and able to solve that 7% throughput issue.
The differentiators that we see Optimal Ops providing is this unified strategy that aligns the data-driven with your other strategies throughout your organization. You're getting that feedback immediately on whether you're performing relative to a target, and the target is meaningful. Most people are walking around fighting fires every day. And what we want to do is move into an environment where we can be proactive every day.